In these notes, we're going to be talking about non-special angles, and this is going to get into the heart of why we use the sum difference formulas when they can be useful to use. And I'm just going to dive right into our first example. Example 1. Find the exact value of sine of 255 degrees. This is really what the previous problems have been preparing you for. We've spent some time practicing just using the expansion and finding the exact value, but this is actually what a problem would look like. 255, it is not on the unit circle. If it were, I wouldn't need the sum difference formulas. Since I can't use the sum difference, or it's not on the unit circle, I can still get to the exact value using the sum difference formulas. The obvious problem here is we need to find two numbers to plug into that formula, our u and our v. In order to do this, we subtract the given angle by 30 degrees, 45 degrees, or 60 degrees to find an angle on the unit circle. So I'm going to go through each of those to see what that would give me. Our given angle is 255 degrees. 255 degrees minus 30 degrees. That's 225 degrees. 225 is on the unit circle, so this would be something we can use. I'll go through all three scenarios here. 255 minus 45 will give us 210. 210 is also on the unit circle, so that's an option to use. And lastly, 255 minus 60, that's 195 degrees. 195 is not on the unit circle, so we wouldn't be able to use that angle pairing. So for the purpose of the formula, you would rewrite the top one. The angles we'd use are 225 and 30 because those are both on the unit circle. So your formula would be 225 plus 30 degrees. And then if we were to use the second pair of angles, it would be 210 plus 45. Now we got two options here. Obviously don't use both of them. You're welcome to. You should get the same answer, but you only pick one of them. So this happens quite often where two pairs work. Sometimes there's only one, but again, it is completely your choice. On the sine and cosine problems, there really isn't an advantage here to picking one over the other. Tangent, there will be a case like that, and I'll get to that when I get to the tangent problem. So for this one, I'm just going to go with the top pairing. Sine of 225 degrees plus 30 degrees equals, using the sum formula, sine of 225 degrees cosine of 30 degrees plus cosine of 225 sine of 30. At this point, I'm not going to write out the point and identify sine and all that, but you're more than welcome to still in your notes if that's helpful to you. I'm just going to look directly on the circle. At 225 degrees, the sine value is negative rad 2 over 2. At 30 degrees, cosine is rad 3 over 2. Plus, at 225, cosine is also negative rad 2 over 2. And at 30 degrees, sine is a half. From here, we just do the math. First, we need to multiply both sets of fractions. Negative rad 2 times rad 3, that's negative rad 6. Over, don't forget to multiply the bottom. 2 times 2 is 4. Plus, negative rad 2 times 1, negative rad 2, over 4. And then the last thing we need to do is just put this together as a single fraction. Negative rad 6, and then I'm just going to put minus rad 2 over 4. Which looks similar to an answer we've gotten before, so that looks good. And then, of course, we can check our answer. The original question was sine of 255 degrees. And then checking this answer. Since it's a fraction, make sure you're using the fraction button. That's alpha x to get there. Negative square root of 6. Minus square root of 2 over 4. And we arrived at the same answer, so we know it's correct. Questions on this first problem? Okay. I'm going to do a cosine, and then a tangent, and then we'll be done. Example number 2, the previous directions apply. I'm just going to write the problem down. Cosine of 165 degrees. We're finding the exact value. Now this time I won't write out all 3 possible angles. I'll just go until I find the first pairing. So 165 degrees minus 30 degrees. That's going to give us 135 degrees, which is on the unit circle. And again, there's no distinct advantage with going over one over the other on sine and cosine, so I'm just going to stick with that pairing. Just taking notes right now. So I'm going to rewrite that as 135 plus 30. And that's the expansion I'll use to solve my problem. Cosine of 135 plus 30. That's cosine of 135, cosine of 30. Cosine does the opposite, so it's not plus, it's minus sine of 135, sine of 30. Looking at the unit circle, 135 degrees, cosine is negative rad 2 over 2. Looking at 30 degrees, cosine is rad 3 over 2. Minus sine at 135 is positive rad 2 over 2. And sine at 30 is a half. Multiplying negative rad 2 times rad 3, that's negative rad 6 over 2 times 2, which is 4. Minus rad 2 times 1, that's rad 2, over 2 times 2, which is 4. And then we just put it together. Negative rad 6 minus rad 2 over 4. And there you have that. Again, I'm going to check my answer in the calculator. And conveniently, that was the same answer I got in the previous problem for sine, so I just have to change this here. I'll just type it in again. Cosine of 165. Yep. Also came out to be the exact same thing. Questions on this problem before we do our final problem, another tangent. Example number 3, same directions apply from before. Tangent of 195 degrees. Now, on the tangent problems, it will always be to your benefit, as I've pointed out before, to use a version of 45 degrees as one of your two angles, because 45 degrees is where tangent is either, well, at 45 specifically, it's 1, but the variations, it's either positive 1 or negative 1. That will make your life just a tad bit easier. So, I'm going to go for that angle specifically. Tangent, use 45 degrees. If it's an option. Just a little helpful hint. So that's what I'm going to go for first. 195 minus 45 is going to get me 150. Which is on the unit circle. So I'll be using 150 plus 45 tangent of 150 plus 45 equals tangent of 150 plus tangent of 45 over 1 minus tangent of 150 times tangent of 45. And I forgot to do my side work, so let's do that real quick. At 150 degrees, the point is negative rad 3 over 2, 1/2. So tangent is equal to 1/2 over negative rad 3 over 2. So that's negative 1 over rad 3. Just move the negative to the top of the fraction. And then I'm not going to show the rationalizing. Hopefully you can follow. That's just going to give me negative rad 3 over 3. Multiply top and bottom by rad 3. And then 45 degrees. Rad 2 over 2 for both values. And I'm going to skip the work on this one. I hope you can follow. If I divide these, y over x, sine over cosine, it's going to be 1, which is why we chose that one. Continuing with the problem, going to substitute those values in there. Tangent at 150, that's negative rad 3 over 3. Plus, tangent at 45 is 1. Over 1 minus negative rad 3 over 3 times 1. Simplifying just a little bit, negative rad 3 over 3 plus 1 over 1, and then you know these will become a positive, so it's just going to be plus rad 3 over 3. Now this top may look a little backwards here. It just depends on the order that the angles are written in the original problem, so that's not an issue. So as you can see, we have the more difficult version of tangent, but it's all right, just an extra step. We need to get rid of these denominators here. So we're going to multiply the top and the bottom of the fraction by that denominator of 3. And don't forget to fully distribute when you do that. Three times negative rad 3 over 3. These are just going to cancel, so it's negative rad 3. Plus 1 times 3 is 3. On the bottom, we have 3 plus, again, these will cancel each other out, square root of 3. Now the current issue is we need to get the radical off the bottom, so we're going to multiply by the conjugate. Times, and it's the conjugate of the bottom, we don't care what the top's doing, the bottom, and we change the sign only in front of the square root. So this is 3 minus the square root of 3, top and bottom. Don't forget, we are foiling here. Negative rad 3 times 3, that's negative 3 rad 3. Negative rad 3 times negative rad 3, that is positive 3. 3 times 3 is 9, so plus 9. 3 times negative rad 3, that is negative 3 rad 3. On the bottom, 3 times 3 is 9. 3 times negative rad 3 is negative 3 rad 3. Rad 3 times 3, that's positive 3 rad 3. And then rad 3 times negative rad 3 is negative 3. We're on the home stretch here. A couple more steps. Let's do the whole numbers first. 3 and 9 will give us 12. Negative 3 rad 3 and negative 3 rad 3. That's negative 6 rad 3. Just combine the numbers in front. On the bottom, 9 minus 3 is 6. And then these should cancel. If they don't, a mistake has been made. Negative 3 rad 3, positive 3 rad 3. Here's where we're at, and I just need to simplify. 12 over 6 plus negative 6 rad 3 over 6. 12 over 6 is 2. And since this will remain negative, I'll change that to a minus. Those cancel, and we get rad 3. 2 minus rad 3, and last but not least, check your answer because you can. So why not make sure that you are 100% correct? Tangent of 195, and 2 minus the square root of 3. There you have it.